geometry. So before we start talking about these angles in the interior and the exterior angles, let's just make sure that we're all on the same page with these polygons that we're going to be referring to. These these shapes are the ones that we need to know about, information about. And so what I want you to do is go ahead and list off. This is going to be number of sides. You need to write that. Number of sides. We're going to talk about a 3-sided polygon, a 4-sided polygon, 5 and 6, 7, 8, 9, 10, 11, and also 12. Okay, so we need to know the number of sides and what we call that type of polygon. If a polygon has 3 sides, what is the name for that? Triangle. That prefix tri means 3, like a trilogy or a tripod. I mean, it's tricycle. It's all over the place. 4-sided figure. What is that? Quadrilateral. You can't make any assumptions. If you said square, then you're assuming that it has 4 congruent sides, and you're also assuming it has 4 congruent angles. You do not know that. You need to get that out of your mind. 4-sided figure is a quadrilateral. We can't make assumptions about these shapes. So we don't know if it's a trapezoid, we don't know if it's a kite, we don't know if it's a rhombus or a parallelogram. We don't know anything. It's just a quadrilateral, and quad means 4. By prefix, quad. 5, what is that shape called? Pentagon. 6, hexa. 7, hepta. H-E-P-T-A. Heptagon. Heptagon. 8, octa. 9. Nice. Nonagon. N-O-N-A-G-O-N. Nonagon. 10. Deca. Like a decade is 10 years. Decagon. 11. This one's kind of difficult. So deca means 10, so we just need to add one more to that. In Spanish, what's, how do you say number 1? No. So we're going to say we need 10 and one more. So we're going to say un, that means 1, un, and then deca. So I know that the Spanish word uno is not in there, but that's where they're getting un from, means 1. And then continuing this kind of thing, the Spanish word for 2 is dos, so do. So a 12-sided figure is a do for 2, and then deca, 10. So this would be a do decagon. Okay. After that, because there exists 13-sided figures, 14-sided figures, 20-sided figures, 45-sided figures, all the way into infinity. Okay? There exist those shapes, but we get lazy, mathematicians, we get lazy, so rather than saying the names for polygons that are 13 and more, what we do instead, if I want to name or if I want to write down and describe a polygon that has 26 sides, there is a special name for it, like this. There is a special name, it exists. But we don't waste our time. We will literally write the number of sides, dash, gone. This is a 26 gone. And so we know that means a 26-sided polygon. 26-sided polygon. And you see that in your homework on page 145. I think there's like a 20-gon or something like that. Oh, there's a lot of them. There's an 11-gon. So your workbook pages were really lazy. They didn't even use undecagon. They just said 11-gon, and then it goes on to 15-gon, 20-gon, 40-gon. So they're just describing a polygon with that many number of sides. Okay, but I expect you to know 3 through 12. So on quizzes and tests, you will write these down. If it gets to 13 and above, then we can just use this notation. Okay? So good, be familiar with these polygons. That would be a great thing. Okay, let's investigate the first 4 of those. Let's investigate the first 4. So triangle, quadrilateral, pentagon, and hexagon. To the best of your ability, we're going to draw each one of those shapes, the first 4, the best we can. Okay? So this is what I mean. Starting on the left, I want you to draw a triangle. We're going to fit 4 shapes. It's going to be a triangle, quadrilateral, pentagon, hexagon. So I have a 3-sided figure, I have a 4-sided figure, I have a 5-sided figure, and a 6-sided figure. We're going to use a variable n, and n stands for the number of sides. So somewhere on this page, it doesn't matter where, but you need to make a note to yourself where n is the number of sides. So for a triangle, n is equal to what? 3. For a quadrilateral, n is equal to 4, and so on and so forth. How many interior angles does a triangle have? 3. The same number of sides, correct? How many interior angles does a quadrilateral have? 4. The same number of sides. How many interior angles does a pentagon have? 5. The same number of sides. Okay, so the number of sides is equal to the number of angles, of interior angles as well. It's always the case. A polygon will have the same number of interior angles as it will sides. Okay? Now, we need to find out some facts about the interior angles. Now, obviously, I drew these randomly, and yours are different, so we don't know what these individual angle measurements are. The only way to find that out is if I bring a protractor up here and actually measure them. But we can find what the sum is. If I add up all 3 of these interior angles, what should I get? I should get 180 degrees. Well, because we've already learned that. We've proved that the 3 interior angles of any triangle add up to be 180 degrees. We're going to use this fact to help us figure out, well, what do these 4 angles have to add up? Well, what do these 5 angles have to add up? And what do these 6 angles have to add up? We're going to use triangles to help us out. What we're going to do is we're going to take each one of these shapes and break it up into non-overlapping triangles. By that I mean, if I draw this, there's triangles in here that are overlapping each other. Like this triangle here is all over top of that triangle. Okay, so we're going to break up these shapes into non-overlapping triangles. So for this quadrilateral, whatever yours looks like, and whatever mine used to look like, I don't know. I want you to draw in one diagonal. Draw in, doesn't matter which one, but one diagonal. By doing so, you have split this one quadrilateral into 2 non-overlapping triangles. And what we see is, I'm trying to, we know that this angle plus this angle plus that angle adds up to 180 degrees. What we're trying to find out right now is like, well, what happens in a quadrilateral? I want to know what's always going to happen when I add up the 4 interior angles. Well, when I break it up into these 2 triangles, I can see that these 2 triangles, they account for all of the 4 quadrilateral interior angles. Well, if I add up the measures of this triangle, these 3 angles, what is that going to be? What is it? 180. What about if I add up all the angle measurements of this triangle? 180 as well. So What about the whole quadrilateral? What's the sum of these 4 interior angles? It's going to be 360 degrees, because 180 plus 180. We're going to do the same thing for this pentagon. I want you to choose your most bottom left vertex, whatever it looks like, wherever it is. I want you to put your pencil on that bottom left vertex. We're going to connect this vertex to the other vertices. You're going to be drawing 2 segments. By doing so, we've broken up this pentagon into how many non-overlapping triangles? 3. So in that triangle, this is 180. In this triangle, that's 180. In that triangle, that's 180 degrees. And we can see that these 3 triangles account for all 5 of these interior angles. So if you have a pentagon, and it does not matter what it looks like, because y'all's pentagons look different than mine, doesn't it? Don't they? Yeah, it's bigger, it's different side lengths, but it doesn't matter. All pentagons, you can break all pentagons up into 3 non-overlapping triangles, and you can add up all their angle measurements. So when we add up the 1, 2, 3, 4, 5 interior angles of a pentagon, what is that sum going to be? What is it? 540. 180 plus 180 plus 180 is going to give us 540. Let's do the same thing for this hexagon, whatever yours looks like. I want you to put your pencil on the bottom most left vertex, and then connect that one vertex to the other vertices. You should be drawing 3 segments this time. Breaking up this hexagon into how many triangles? 4. So what does it seem like is happening? Every single time we add a side, right? Because this was 3 sides, this is 4 sides, this is 5 sides and 6 sides. Every single time I'm adding a side, what's happening to the number of triangles?
It's being added by 1.
Yeah, it's increasing by 1 every single time I add a side. Okay? So if this is the case, what are these 6 interior angles of a hexagon going to add up to? 720 degrees. So there's a couple of things that we need to realize. First, let's look at, or let's write down what we notice about the number of triangles. So in red ink, I'm going to have number of triangles. Okay, I've written this underneath the triangle because obviously there's 1 triangle in a triangle. But for here, how many triangles go in this quadrilateral? 2. And in this pentagon?
3.
And in this hexagon?
4.
4. And then let's just talk about it. How were the sum? Okay, so what we need to write here, this is the sum, meaning adding up sum of the interior angles. We're adding up the measures of the interior angles. How is that changing as I add a side? So this started off at 180. How is it changing as I add a side?
You're adding 180 each time.
You're adding 180 because 1 more triangle can fit into the next shape. How is the number of triangles related to the sum of the interior angles? How is the number of triangles that fit into the shape related to the sum of the triangles? So how is the number of triangles that fit inside this shape? How is that related to the number of sides? Goodness, I'm so sorry. How is it related to the number of sides? So if I said you had, here's a new column right here. You had n sides, you didn't know. How would I figure out the number of triangles that fit in there? 2 less than the sides. Okay? So I would take the number of sides and I would minus 2. And that would tell me how many triangles fit in there. Okay? 3 sides, 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. We're just taking. So right, the number of sides, we subtract 2, and that's how many triangles can fit in there. Then we took that number and we multiplied it by 180.